Welcome to Study Session 7, Introduction to Information Systems. Introduction. An information system is a type of fabricated system that is used by one or more persons to help accomplish a task or assignment. Information systems come in all shapes and sizes and are limited only by human imagination. For example, you may have an address book that lists the names, addresses, and telephone numbers of your friends and relatives. When you want to call one of them, you refer to your book to get the phone number. If you desire to send your rich aunt a get well card, of course you are sincere about this. You look up her address in a book when addressing the envelope. On a much larger scale, the major airline companies have massive information systems to handle passenger reservations and baggage. Learning outcome. At the end of this study session, you should be able to define information systems, explain the architecture of information systems, explain the classification of data models, explain the relational data modes and types of information systems. Introduction to Information Systems. What is an information system? It is a combination of hardware, software, infrastructure, and trained personnel organized to facilitate planning, control, coordination, and decision-making in an organization. Information systems are established to support policies and/or procedures. This can be done in virtually limitless ways. For example, you may have a mental policy stating that you will maintain an address book. In addition to having the 6 general system components, an information system has 3 additional components: people, procedures, and data. People interface in some way with a system. Sometimes we provide the input, sometimes we do the processing, sometimes we do the input, we do the output, sometimes we do the controlling, and sometimes we provide the feedback. The way we are supposed to interface with the information system is often documented in the form of procedures, and our interaction usually results in providing data to the system. When one of your relatives changes his or her address, you have a procedure, undocumented, no doubt, for providing new data to replace the obsolete data in your address book. As the amount of time maintained an information system increases, or the number of people needed to maintain it increases, it becomes economically justifiable to invest in an automated information system to accomplish the task. For example, many people who write personal checks have purchased personal money manager software to help them with the task of paying their bills by check and balancing their checkbook. Most people can do this task manually, but a personal money manager information system may reduce the time and efforts to do the same thing. In addition, paying bills may actually be viewed as a more enjoyable task with the use of a personal money manager information system. Characteristics of an information system. The basic characteristics that exist within an information system are data, functions, and behavior. Information systems do not necessarily need to have all 3 characteristics, but most do. Data are either input via some data entry device such as a keyboard, scanner, or mouse, already in the system and stored on a storage device, such as a magnetic disk or diskette, or displayed or printed on an output medium, such as a display screen, paper, or microfilm. As part of the information system, data that are input and data that are restored, pictures that are stored are transformed or processed into meaningful output data called information. For example, in a payroll information system, the hours that employees work in a pay period and the hourly wage they are paid are important pieces of data for computing an employee's payroll check. The hours worked are data that needs to be input each pay period, while the employee's hourly wage is stored data since it only changes when the employees get a raise. A function is a transformation or action taken by the information system. Information systems usually have many functions. Functions carry out and enforce business policies, rules, procedures. Other synonyms for function are process, service, and method, the last two becoming more familiar with the popularization of object-oriented technologies. Examples of functions are printing a report, printing a paycheck, displaying the customer's account's dollar balance, and dispensing cash from an ATM. Data functions behavior. Data equals input, stored or output. Function, business activity performed. Behavior, the observable effect of a request. In information systems, behavior is the observable effect of a request. Behavior is present in all systems. However, it is more pronounced or accentuated in systems that have a human interface component. Systems that respond to keyboard data entry, command or mouse clicks, such as word processors, spreadsheets, email, and other systems. In addition, a furnace motor turning on or off in response to a thermometer reaching a certain temperature, a bottle filling device responding to messages like fill bottle and full bottle, and an elevator responding to signals that its information system receives as it passes by actuators on the way up or down the elevator shafts are all examples of behavior in systems that have minimal human interaction. Report or block. If you block this user, you will remove the user as a friend and you can no longer write to each other or become friends. You can always unlock users in the settings. If you report this user, a moderator will be notified of any inappropriate behavior. This does not automatically ban a user from the game. Different types of information systems may emphasize one or more of these three characteristics over the others. In typical business information systems, the primary emphasis is usually on the data component, with secondary emphasis placed on the functional aspect, followed by the behavior. Why is this? Because in most business information systems, such as accounts payable and receivable, purchasing and manufacturing, bill of materials, material requirements planning, payroll and other entry, the data are the primary component. In elevator information systems, the primary emphasis may be on the behavioral component, while realizing that it must also give attention to the functional and data component. Historically, business information systems were developed primarily from a functional perspective, while being aware that these systems also had a strong data component. Since the mid-1970s and the introduction of database management systems and relational database technology, the functional perspective for developing business information systems has often been relegated to a lesser position in favor of a data perspective. However, the need to give primary consideration to the functional component may still be present in some types of information systems, and some businesses no doubt will prefer to practice using a functional perspective instead of a data or favorable position. Architecture of information systems. From a primitive point of view, we can visualize an information system as a combination of three main components: application layer, data management layer, database, data repository. Application layer. This implements purpose-oriented data processing algorithms and a particular user interface. There are no common solutions, which are used for designing different information systems. For example, a project management system, electronic library, financial transaction system, computer-based training system, and so on, require essentially different data processing algorithms and user interfaces. Data management layer provides data structures and operations to be utilized by the application layer. Formally, a combination of data structures and data processing operations supported by the data management layer is called a data model. We can speak about information systems based on a file management system, on a relational data model, on World Wide Web, etc. In other words, information systems may be based on different data models. It should be especially noted that essentially different information systems may be based on one at the same time and the same data model. Operation between application and data management layers, application layer, logical data model, data structure plus operations, data management layer. For example, a collaborative document authoring system and a university information system might well utilize one and the same relational data model. Application layer X, application layer Y, logical data model, data structure plus operations, data management layer. Classification of data models. Data management principles are essentially different depending on nature of information to be processed. Thus, we can speak at least about well-structured data, ill-structured data. We speak about well-structured data if structure of data objects may be separated from its actual content. In other words, there are a number of data objects having identical structure, metastructure. In this case, any data object is just an instance of a previously defined data type. Well-structured data management is based on so-called database technology. Database schema contains a description of all data types which are of interest to users. Database contains instances of the data types previously defined in the database schema. Classification of data models. Meta schema, database schema. To build a database administrator has to accurately define a particular database schema. Application layer programmers apply a collection of operators which are supported by the DBMS to retrieve, store, or modify data. Note that data objects are created as instances of previously defined data types, that is, by filling predefined forms with actual data. Figure 710 shows DBMS of a well-structured data. Thus, a DBMS maintains two different but closely connected languages. Data description language (DDL) is applied to define database schemata. Data manipulation language (DML) is a collection of operators to create, access, and modify databases. We speak about ill-structured data if structure of a data object cannot be separated from its actual content. In other words, each data object may have a unique data structure which is coded as a part of the actual content. Manfred Lamb was born 1940 in Vienna, Austria, married, 2 children, Erna 1960 and Louise 1964. Hi, I'm John. I live in Paris and I love pets. This is my cat, Fabi. In order to work with ill-structured data, data objects are coded, authored, using special data encoding markup language. References to other objects are inserted directly into the object code. Embedded links. Special software interprets such objects' code. For example, World Wide Web utilizes HTML as the data encoding and standard software packages Internet browsers to interpret this code. Such systems are normally referred to as first-generation hypermedia systems. Second-generation hypermedia supports meta-language, that is, general mechanisms, which can be used to define application-oriented data encoding paradigms. For example, extensible markup language, XML, and cascading style sheets, CSS. Meta-language allows managing any information in a platform and vendor-neutral way, and then easily sharing this information with any other application. Second-generation hypermedia, meta-language, administrator, application-oriented, author. Syntax description paradigm, syntax schema. Semantic definition paradigm, semantics, data objects. Second-generation hypermedia operates with higher-level data structure called hypermedia composites. Hypermedia composites may be seen as structured collections of data objects and other composites. Composites facilitate collaborative authority, usability, and integrity of hypermedia systems. Thus, we can see a comparison of these two data management techniques as follows. Database users, which field templates are predefined in the database schema. DBMS, database administrator, database schema, straitjacket, database technology. Hypermedia technology, freehand hypermedia authority, hypermedia system. Relational data model overview. Relational data model allows operating with a database as with collection of two-dimensional tables called relations. Tuples, that is data objects, are related by means of so-called foreign key and primary key relationships. A relational database schema may be seen as a definition of a number of relations tables. Each relation is defined as a unique name with a list of domains which corresponds to columns of the relation. For example, customer, C name, C city, phone, product, P name, price, transaction, C, P, date, quantity. To insert, put new tuples into a particular relation declared in a current database schema. Step 1. A user, an application program, chooses a relation, say customer. Step 2. The user program prepares a new tuple of the relation on the screen or in the computer's memory. Step 3. The DBMS put a new tuple into the relation database. Relational data model automatically supports so-called referential integrity. A foreign key can have only two possible values, either its relevant primary key value or null value. No other values are permitted. The most popular relational query language is called SQL, Structured Query Language. The basic operation in SQL is called mapping, which transforms values from a database to user requirements. This operation is syntactically represented by the SQL block. SQL blocks may be nested in order to implement more complex queries. Consider, for example, the following query. Get names of such customers who bought the product CPU. According to Loudon 2001, the purpose of computer-based information systems is to provide managers and various categories of employees with the appropriate kind of information to help them make decisions. The 6 major types of information systems corresponding to each organizational level. The 4 levels shown in figure are: types of information systems, Western, strategic level, senior managers, management level, mobile managers, knowledge level, knowledge and data services, operational level, operational managers. Let us now examine different types of information systems available. Transaction processing systems, TPS, serve the operational level of an organization. It is a computer-based information system that keeps track of the transactions needed to conduct business. It records day-to-day transactions. Pick 2. It records day-to-day transactions such as customer orders, bills, inventory levels, and production output. It also helps to generate databases that act as the foundation for the other information systems. Types of information systems. Knowledge Work Systems, KWS, is also known as expert systems, ES. Expert systems is a set of interactive computer programs that help users solve problems that would otherwise require the assistance of a human expert. It is also known as knowledge-based system, KBS. Office automation systems, OAS, to serve the knowledge level of an organization. Pick 2. It is a computer-based information system intended for workers or employees of all levels, which combines various technologies to reduce the manual labor required in operating in an efficient office environment. Decision support systems is a computer-based information system that provides a flexible tool for data analysis. It helps in predicting changes that may influence the data in the future. It simply analyzes data. It helps to analyze a wide range of problems, such as the effect of events and trends outside an organization, like the MIS. The DAS draws on the detailed data of the transaction processing system. Management Information Systems, MIS, serve the management level of the organization. It is a computer-based information system that produces standardized reports in a summarized, structured form. Executive Support Systems, ESS, serve the strategic level of an organization. It is an easy-to-use system that presents information in a very highly summarized form. It helps in developing strategic plans and decision-making. It is also known as Executive Information Systems. Study Session Summary. In this lesson, you have learned that an information system is a type of fabricated system that is used by one or more persons to help accomplish a task or assignment. That an information system is typically characterized by data, functions, and behavior. That an information system is a combination of an application layer, a database management layer, and a data repository. That data is classified according to their structure as either well structured or ill structured. End of study session 7. Thanks for listening.